So we'll start with part A, finding speed. So we start off by setting FG equal to FG, FC equal to FG. We get mv squared over r is equal to gmm over 2r squared, because it's distance from center to center, and then this one's distance from the middle to the mass to the pivot, and we know the pivot's going to be equidistant from the stars because it's a binary star system where the masses are the same. So we can cancel out the m's and the r's. So we get v squared is equal to gm over 4r. So I'll move it up here when I rewrite it. So v is going to be equal to gm over 4r after we square root it. Part B. Then let's find the period. So we're going to t is equal to 2 pi r, which is the circumference, over velocity. I'm going to square both sides, so 4 pi r squared, 4 pi squared r squared over v squared. So you can plug v squared in easily. So I'll write down here again, 2 to the 4 pi squared r squared over gm over 4r. You can write that as a fraction times 4r over gm. So t squared is going to be equal to 16 pi squared r cubed over gm. And when we square both sides, the period, we get t is equal to 4 pi radical r cubed over gm. On to part C, on total energy. So E total is equal to K plus U. And here it's going to be 2K for each of the stars that have their own kinetic energy, minus U, since there's potential energy that binds the star system together. So it's going to be 2 1/2 mv squared minus U. Cancel out those. So we're left with m. V squared from earlier we know is gm over 4r minus u, so m, so gmm for r. We know that u is just gmm over 2r, and that is going to equal to gmm over 4r, and it's negative. And that's Ke total. And that's the energy total. D, then what else is? So L, the system, is going to be equal to CPR, equal to MVR, since these are both point masses. It's going to be 2 MVR, because there's each of the planets will have their own angular momentum. We need to add them together. Okay. So it's 2m. The V is going to be gm over 4r. And then the r is just going to be r. And then I'm just going to do some side work. So 2mr is equal to square root of 4m squared r squared. So radical gm over 4r. You multiply that against 4m squared r squared square root. Okay, cancel out the 4's, cancel out one of the r's. So we're going to get radical gm cubed r will be our L cis. Okay, for part E, I'll solve for the center of mass first, since it's a new masses. So xcm new is going to be 3m 0, since my perspective will be from the 3m mass, plus m, and then the total distance is 2r, and then 4m on the bottom, so that's 3m plus 1m. This is out. So it'll be r over 2 will be our new pivot. And I'll draw down here so I have more space. Maybe here, 3m. So this distance will be r over 2, r over 2, and this will be our pivot. Another r over 2, and our last r over 2. This is where our other m mass will be. Okay, and I'll draw the orbits now. And that's my best attempt at a circle. F, we want the angular speed. No, yeah, F, we want the angular speed. So that means we have to find the orbital speed first of the 3m mass. So it's 3m v squared, and it's gonna be 1/2 r now, since that's the new distance from this 3m mass to the pivot. G, still 3m, m, and the bottom will be still 2r squared, because that's still the distance from center to center. So simplify this down to 6m v squared over r equals 3gm m over 4r squared. Cancel out some numbers again. So we get 6v squared is equal to 3gm over 4r. I will divide both sides by 6. So we get v squared equal to, and cancel one out, so gm over 8r. So v is going to be equal to the 3 of the 3m mass will be equal to gm over 8r square root. For g, he says that the new period, the period of 3m will be bigger than the period of the smaller m. And we know that's whack because in a binary star system, t1 is equal to t2. But we also know this because t is equal to 2 pi radical d squared over g m total. We see that the bottom here relies on m total. So no matter what perspective you use, you're still going to be depending on m total. So that means it'll be the same for both. Okay, for h now, they want to see the new period has increased or decreased or remain unchanged. So t naught is equal to 2 pi radical d squared over g m total. Okay, and when we expand that out, it's gonna be 2 pi 2r squared, 2r cubed over 2gm. This is m plus m for the original one. And this simplifies down to 2 pi, and it's gonna be 4r cubed over gm. Okay, time for t new. T new is 2 pi, same function, gm total, 2 pi, 2r, it's messy, 2r cubed. And instead, this one's gonna be 4gm, since it's 3m plus m. And when that cancels out, it's gonna be 2r cubed gm. And we see that t naught is bigger than t new, so that means that the period has decreased when we increase the mass of one of them. Okay, time for I now. So on the ratio of the orbital speeds, we already know the speed of the 3m one, so we just need to find the other m. So v squared over 3 over 2r, since the other one was 1/2 r. So this is going to be equal to to g 3m m over 2r squared, and it's still distance from center to center. Gonna flip the fraction, 3mv v squared 3r is equal to 3gm squared over 4r squared. Cancel the m's and r's, and then multiply both sides by 3 over 2. So we get v squared, it's going to be equal to 9gm over 8r. Get both sides, so we get v is equal to radical 9gm over 8r. We're going to set v3m over vm. So we know from earlier that v3m is radical gm over 8r, and we know that v of the regular m is just gm 9gm over 8r. 8r. Cancel out everything but the radical 9. So we get 1 over radical 9. So 1/3. For j, we can use a shortcut. So L is equal to CPR is equal to MVR, because C is just a point mass. Since they're just point masses, there's no C. So I'll just set up like this. So L3m is equal to Lm, and that's going to be equal to 3m V3m over 1/2 R over m Vm over 3/2R. And here I can cancel the m's, cancel the r's. I already know this ratio from earlier, so we actually get left with 3/2 on the top, 3/2 on the bottom, times the 1/3 from earlier. These cancel out, so our final answer will actually just be 1/3 again. Actually, type of K. So now we actually need to solve for L3m and L6. So L3m is just going to be equal to 3m radical gm over 8r, or sorry, v from earlier, times 1/2 r. I'll simplify this down to 3/2 mr radical gm over 8r. L6 now will be equal to 3/2 mr, and this one is the 3 mass, 3m mass, plus, and this one will be the 1m mass. So it's m, the speed of this one is 9gm over 8r, and the ratio, and the r here will be 3/2r. Okay, 3/2 mr radical gm 8r. Here I'm gonna pull out this 9, so it'll be 9/2 mr radical gm over 8r to make it easier later on. Okay, and this is gonna be equal to 12 in total. Mr, write out one more time. R. Now we can divide L3m over L6. That's gonna be equal to 3/2 mr gm over 8r, all divided by 12/2 mr radical gm over 8r. Cancel, 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 cancel. This will pull out a 4, so it'll be 1/4, and that's our answer. Okay, last one. They want us to do L. So we know Km will just be 1/2 mv squared. And we know that here it's gonna be 1/2 m. It's gonna be 9gm over 8r. K3m is gonna be equal to 1/2 3m v squared. The v squared here is gonna be 1/2 3m. Sorry, no, we don't want that. It's gonna be regular gm over ar instead of 9. We divide 2, km on the bottom. Sorry, on the bottom. We get 1/2, or I can pull out the 9. So it's 9/2 m times gm 8r. This will be over 3/2 m gm over 8r. Again, cancel, 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 cancel. And we will have 3 as our ratio.